I didn't sleep a lot, so when I don't sleep enough, this interferes with my language capabilities. So maybe I'm gonna start saying funny words. This is just German, yeah? Okay, don't freak out. Yeah, I'm gonna talk about, yeah, no, it's a stupid title, but anyway, I'm gonna talk really briefly about the following problem. So, how do you do if you want to look for vulnerabilities in software that is used in some kind of proprietary protocol, undocumented protocol? This is hell. Yeah? So, is Martin here? Is the P guy? Hi, Martin. So it's somehow related with your problem. It's a completely different approach. I'm going to be focusing on some kind of client-server architecture that's talking about through the network. And yeah, I've been given the honor of closing the BruCON. So I just said, okay, this is some kind of reverse keynote. This is really cool. So guys, really quick. I know the title is really stupid, but there was another title I considered before. It was something like, I just met you, this is crazy, but here's my pointer, suggested maybe, and it was like really long, so just say, okay, maybe all your pointer I belong to. Guys, enough of this shit, yeah, okay? There's enough of this shit on the internet. How fast your mother? Yeah, and then I kept thinking, but all the other titles could lead to discussion, yeah, to say it like, that means somebody's gonna kick me in the balls. Oh, yeah, punch me in the face. So overview, really quick. I'm gonna do a really fast introduction. Then this is gonna be like 5 minutes, fasting 101. I mean, like really the basics. I know it's like, but anyway, we need it. Then we're gonna see that fasting, it really doesn't work when you have a proprietary protocol because you don't have any information at all. Makes sense. We need a different approach. So the approach I'm going to take is to abuse the client. Yeah? Remember, there's some kind of client network, client-server architecture, and then talking through some proprietary, undocumented, really obscure protocol. Then I'm going to talk about some possible implementation, because of course I code some stuff. This is not exactly a tool, but there's some really nice code, and I call it Boyka. Does anybody know who Boyka is? Sorry? Ah, the Spirit 3! This guy, 2! This guy is really fucked up. Okay, just like me, you're gonna say it after that. Then I'm gonna do an experiment, because I thought, I'm gonna do a demo. No, a friend of mine always says, don't do a demo, because if it goes wrong, then you're fucked. It's an experiment. If it doesn't work, well, it was an experiment. And then really good a conclusion. So, who am I? Yeah, compared to the people there, because maybe you're thinking, who the fuck is this guy? I know Ed Scudis, yeah? I mean, I know Joe Foreman, who is this guy? Well, I'm actually like the user nobody, yeah? I'm working on privilege escalation. I come originally from Spain, maybe you can hear it in crappy accent, but I've been living in Germany since 5 years or more. Word is actually a cliche right now. I studied particle physics, a long time ago. I'm really old, and then I realized the Wikipedia page, if you look for physics major, it redirects to engineer. That means nobody cares about this stuff. The physics is like physical. What do you do with this? So yeah, I just ended with some IT security stuff, which anyway is really more interesting. It's really important to know what this is about. So, you can read here, it's an interesting, or at least I think it's really interesting approach to software testing, so fuzzing. It's about touching things you're not supposed to. We all love this stuff. It's about breaking stuff, but only if we are really lucky. I'm gonna do this experiment, and I hope to break some stuff. And this is very important, because I forgot something. Can you give me the back? There's gonna be a lot of reference to pop culture. I mean, I'm gonna do some questions. It's gonna be Belgian chocolate, of course. It's the red bag. It's a red paper bag. Oh, this one. Thank you very much. So I'm gonna do some questions as well. Yeah, that has nothing to do with technique. It's okay. Thank you very much. You can just answer. It's more like pop culture. I cannot believe you know who Vodka is. A flashlight. Okay, everybody loves chocolate, of course. I have some chocolate. I'm gonna throw it to you. If you know the answer, it's gonna be like really difficult for me to throw it. So maybe I'm gonna give it to you later. And just look for this chocolate quiz icon. Yeah? There's some slides with this. When you see this thing, then you say, hey, what's the question? Give me the chocolate. I have a lot of chocolate. It's really important as well what this is not about. Yeah. So people doesn't get disappointed. It's not a tool, as I said before. It's not that you're not gonna get a tool so you can click and I'm charging my legs. It's nothing like that. There's a lot of code, everything online. You can play with it after that if you want. And I really think this is incredibly awesome. What I'm gonna do. But maybe you don't, so that's okay. It's really important to know I did this in my spare time, so you have to set your expectations accordingly. Yeah? But it's actually pretty nice. Do you want to leave the room? Please don't, because we're like 20 people. Are you still recording?
Yeah.
That would be good. Very good. So there's chocolate, guys. Don't leave.
Oh, it's also being live streamed. I don't know how many viewers we have there.
This is very cool because my mom and my wife, so two of the three women in my life, they're watching this. Yeah, the third one is Ida. Maybe you know about her. Yeah, okay. I talk about finding vulnerabilities. You need a disclaimer. Are you to the Ida Pro guys? Are you to the hex rate guys? You're awesome. Yeah, you need a disclaimer, man. So this is just for educational purposes only, yeah? Look at this trustworthy guy. Okay, really quick, Fuzzing 101, yeah? It's gonna be like 5 minutes. Who has some exposure to this topic, to fuzzing? Just like, you did something cool, so maybe you're thinking right now, I know this stuff already, but it's gonna be like 5 minutes. It's really necessary just to give some context and to put everybody up to speed. So this is my favorite non-technical definition. It's funny because it's true. Well, it's exactly like that. Because BruCON! Yeah, fuzzing is some kind of brute forcing. There's some kind of, intelligent, semi-intelligent brute forcing. How does it work, actually? I'm gonna do like really quick this example with FTP, because FTP is a really simple protocol. Everyone knows how FTP works. You have to, if you want to find some vulnerabilities in FTP, you want to fuzz the FTP protocol. What you do is, you start like modeling the protocol. For example, you see there, you know there are some blocks. For example, you have the common user, then the username, then the common pass, then the password, etc. Every protocol has some blocks, some basic blocks, and there are some dependencies between those blocks. For example, here on the right, of course you have to send first the user, whatever, and then the password, not the other way around. I mean, there's also some dependencies and some other issues. But it's really important. I'm going to say like 1,000 times, you have to know the protocol, so you can model the protocol, okay? So you just generate those packets because you know the protocol, and they're like some semi-valid packets because the protocol is right, but the values are like kinky, yeah? They're like strange values. For example, you send user, and instead of Carlos, you send like user 1000 A's, yeah? And you start testing, then you wait. It's really like brute forcing. Testing. And eventually, chocolate paste. And eventually, you're gonna bump into a crash. You know? The details here are not important, it's just the idea. You're gonna bump into a crash. Okay, really easy one. Who's this guy? I don't have that much chocolate. Who said it? Sorry. Watch out! Sorry. If you have glasses, okay. If not, be really careful. Okay, you're gonna bump into crashes. The server is gonna crash because the values are, yeah, funky. This is the whole idea. It's really important that you record as much information as possible about the protocol, because some of them crashes indicate that maybe you have some memory corruption and you can exploit these crashes, or what happens with the crashes. This example is like the very typical, you control this EIP register, then game over, yeah? Owned. Okay, there's always a bad, you know? What happens, this is the whole idea, what happens if you don't know the protocol? Once again, you need to know the protocol. You cannot just try to throw to the server a bunch of bytes. Yeah, this is called downpassing. If you don't have the documentation at all, yeah, things get really ugly. You know, in a hurry, that leads to depression usually. Like, do you know this girl? There's no chocolate, but do you know this girl? The show? How I Met Your Mother, exactly. That was quite okay. So remember, you cannot, or maybe you think, well, I can always try downpassing. There's a reason why it's called downpassing. Yeah. So maybe you're thinking, okay, I don't know the protocol. I just see like a bunch of bytes and bits there. I'm gonna take this one and I'm gonna change it, and then I'm gonna send this to my server, and this is gonna work for sure. No, it's not gonna work because once again, you don't know the protocol. Those packets are not really compliant packets with the protocol, so you're gonna get rejected like really easy, with high probability. Just to get an idea of the dimensions of the problem, yeah? Think about this really simple example. You have a packet. There's some data, no matter what, and there's a checksum of this data. Yeah? Think just this checksum is on SHA1, that means it's 160 bits, so you have, if you really want to create a compliant packet or a right packet, or a packet that's not going to be rejected by the server, the probability to get it right is 1 in 2 to 160. So you're going to get one possibility right in 1 kilo tera mega possibilities. Yeah? So in a case like this, it is a really simple thing. You can do it downpassing, well, the same thing you do with the toilet paper. You get the idea? So we're screwed. You are such a bunch of nerds. Does anybody want to solve, by the way? Okay. Very good. So we're screwed, it looks like, yeah? So what do you think? Are we screwed? I mean, is everything lost? That would be really nice. I say like, okay guys, thank you very much. That was really cool. Then I go, we all go home. No, sorry. So no, it's not everything lost. We just need a slightly different approach. Yeah? So, in a nutshell, yeah, everything boils down to a very simple idea. You gotta have one of those. It's actually very simple. Because even if the protocol is not documented, the client knows how to speak the protocol. Yeah, that's true. So I'm gonna focus on the client. I'm gonna say, what is what you know? Yeah, this looks like really nasty. Yeah? Not I approach full. I mean this particular chunk. I mean, if you're reversing some protocol, you don't wanna find this because I mean I really know this slide for months. I have no idea what this is. No idea what this is. How do you implement this technically? So you gotta search the client software, so the client binary. You gotta do a little bit of reverse engineering, and I can see it. Move this stuff. It was very cool. Thank you. Okay, where was I before? I was blank by this guy. Yeah, that's right. You gotta do some reverse engineering of the client binary, and it, as you will see, is everything about getting a feeling It's not about reversing every single thing, everything perfectly. It's about getting a feeling how things work there. So try to locate some functions that look like this, because those functions quite probably are implementing some kind of crypto or hashing. It's really easy actually to spot this one because they have a lot of binary bitwise operators and floating point and all these things. So if you look at this, you say, okay, this is doing something really crazy. Does anybody know what this is? I mean, why there's a graph suddenly here? Okay, really quick. A binary is usually represented as a graph. Yeah? Each one of those nodes, those boxes are the functions, and the arrows mean some calls between the functions. Yeah? So in this particular case, this yellow mark function, that's actually this one, it's pretty close to this send function, the function that sends bytes through the network. Yeah? I mean, you can see this one calls this, another one that calls the send. So kind of indirectly they're connected. Yeah? I mean, it's really graphical. And this is really important as well because, as I said, you're gonna get a feeling of the binary. Of course, those functions that implement, or most of the time, those functions that implement this proprietary protocol are gonna be near, and I say near this function. Or ultimately, are gonna call because they're gonna implement the protocol. They're gonna write some hashes, or they're gonna do some stuff, and then they're gonna send it through the network. That's the idea. So you gotta locate those kind of functions, and another condition is those functions are somehow connected to send, right? Because ultimately you want to send the packet. And when you spot those promising functions, then you gotta check the arguments. In this case, it's really cool because they're really simple arguments. I mean, there's nothing like complex structures or something like that. This is just a pointer to a string that I can go to its address, what's here, and two other integers, two numbers. So cool. So this is basically the idea. And I'm getting excited. Maybe I'm getting excited. I don't know you. No, you're not. Okay, I'm getting excited. Yeah? Because think about this. No, there's no chocolate here. So. It's okay. Those functions are implementing somehow the protocol. They're really obscure parts of the protocol. Yeah? They're writing the hashes, so they're doing some kind of obscure thing. What happens if I can somehow intercept those functions when the client is running, and I can maybe change those arguments on the fly? I mean, somehow I'm going to be able to inject my values instead of the really good arguments. I'm going to try to inject my really, really bad values inside this function, and I'm going to say to the client, well, just do what you do, the protocol related operations, do the hashes, do the encryption, do the thing for me. Yeah? So I'm going to leverage the client to do the heavy lifting, yeah? Because I don't want to reverse all this stuff because I'm really lazy. Nobody say, please nobody say like, yeah, because you're Spanish. No. Because I get that a lot. Okay, so everything is clear until here. The idea, I mean, the details is not important, but the idea that I want to, yeah, no, you don't answer because there's no chocolate. Okay. Yeah, the next two slides are really quick, just for the sake of completeness. Yeah, the details are not important. I just used this combination of these two really cool frameworks in order to implement all this stuff. You're gonna get the details in a moment. Yeah? Microsoft Details is a really cool thing, but Intel Pin, do you know anything about Intel Pin? You know everything. This is really awesome stuff. Huh? So really quick, Microsoft Details, I like it. Really quick, there's a library for intercepting arbitrary with 32 binary functions. That's like a mouthful. What is the meaning of intercepting right here? Well, it's something I mentioned before. What happens here is I'm gonna say, okay, this function is interesting for me, so Microsoft Leaders is gonna somehow mark it. When the execution hits this interesting function, it's gonna stop, and then it's gonna say, okay, instead of running the function, what I'm gonna do is either it's gonna let me execute my code instead of the function, so overwriting completely, but this is right now not interesting for me, or it's gonna let me write some code, run some code in addition to this function. So I'm gonna extend somehow the functionality. Okay? Mati, how am I doing?
Good.
Thank you very much. We support each other. Okay, interpin, this is really cool stuff. But the details are really complicated. Yeah? Let's just say right now, this lets you do everything you want with the binary. I mean, it's like you use interpin, the binary is your bitch. And I'm gonna use it to perform some differential debugging afterwards, just for that. Oh my fucking god! A naked guy, like what the fuck is this? Bear with it, yeah? Whoa, that was like for an A, eh? In the movie Dead Fly, do you know? Whoa, that was good. Ouch. Do you happen to know the name of the character in this film? That would be awesome. Yeah, well, the Fly. It's actually great that Seth Brandle / the Fly. Yeah, Seth Brandle. Why is this here? Because I love the film. And the guy said in a moment in the film, I just put together some things that people more intelligent than me did. So this is exactly what I did. If you check the code is online. I'm gonna give you the link afterwards. I mean, you can see like 3 different styles in a file. So it looks like really funny. Maybe you did some copy and paste. Okay, his experiment didn't work very well. Mine, I hope it's a little bit better. Anyway, I'm gonna get converted to a Fly. So, where's exactly the lab setup, so to say, or the experiment setup? Well, once again, you have the client, you have the server, and they talk through this proprietary protocol. I mean, the client takes some data, maybe some data taken for you, internal data. It's going to assemble a packet, it's going to do some operations, assemble a packet, a network packet, and then send it through the network. So the developers, I can say developers without thinking developers. The developers think that this guy's a developer, they're like really overconfident because they say like, what? Nothing can happen because this is what they think. You can't touch this, because well, it's proprietary, undocumented, obscure. But I'm not really interested in this stuff, So actually the question is, can't touch this, And I want to move the attack point not to the network. I don't want to modify the packets. I want to manipulate, to abuse, sounds really nasty, to abuse the client. So here the developers just losing the cool. They're like, oh, maybe there's something wrong. And of course I can, that's why I'm here. And you can, with some work, you can find or pinpoint some interesting spots. And then I say, okay, I'm gonna check what this does. And I don't know, I just say, okay, this function accepts some arguments. And at the end there's like a chunk of bytes. I don't know what this is. There's 200 arithmetic operations there. It's gonna take me 3 weeks to reverse doing this. But it's okay. You can do it. I mean, actually, you can manipulate the client to do the work for you. And yeah, of course, the developers just completely freaking out right now. Like, so, long story short, this is me saying the client, so yeah, swap it. Very nice. I know I'm repeating some things a lot, but I'm doing it on purpose. So everything clear? Yeah, the dev puppet, of course. Okay, so let's check briefly and discuss the internals, yeah? What I'm doing behind the curtain. Okay. This is actually pretty easy, but it's just the drawing is really shit, but it's pretty easy, and it's maybe the most important slide of the whole presentation. Yeah? Okay, what do we have here? Again, the client, the server. They talk to the protocol. Carlos, you're really annoying. Okay, so my infrastructure, the infrastructure I want to test, has two different parts. So it makes sense that the software I'm going to write to check this software has two parts as well. Yeah? There's something called debugger here. So I call it like BruCON console and BruCON monitor because I don't have any imagination. So on the left, this is the server. This is where I'm interested in fuzz. I want to find a bug there, and really badly. Yeah? We all like bugs. But it's really important, as I said before, that if something happens on the server, that I need to know that something happened. So actually this BruCON monitor that monitors the server, of course, is essentially a glorified Win32 debugger. So I wrote the whole thing, the Windows debugger from scratch, a small one, and don't do that because your eyes bleed at the end. The API is horrible. But well, what it does essentially is just this. It just appends to the server and checks. It's essentially the same thing if you open with debugger attached. So it's the same. The client, yeah, this is the real, the heavy lifting, yeah, is done here. So this BruCON console, what does it do? It attaches some kind of a debugger as well, and some bigger debugger. It attaches to this client software. It's the one that changes the values on the fly as well, and the one that is gonna do something else, but I'm gonna tell you in a moment. And both of these components, they have like a really primitive communications model. That's a really cool name for such a small thing, and they just talk to each other, so they coordinate the attack. Yeah? So they everything's cool, oh, there was a crash, let's record this time. Okay, and the client looks funny. I mean, again, this graph stuff. And I marked 3 functions there. F1, that calls F2, that calls F3, and whatever. Why there's 2 red and 1 green? Okay. This is something like a zoom. This stuff. Good. Where's all this? So let's assume, like I said before, you have found a very interesting function, and you're pretty sure this is implementing some funky protocol, and you want to change the values, the arguments on the fly. Okay, this would be this F2, this green thing. So this is what you have to hook. And this F1 and F3 are somehow arbitrary functions. It's not very important actually, but think about this. You run your client, your software, then initialize, starts doing stuff, hits some functions, then hits this F1, arbitrary one. Okay, it keeps executing this 3 dots, of course, there's a lot of functions in between, but I cannot paint this. So hits F1, keeps executing, hits F2, this is the really important one. Then you change the values here on the fly. The really nice here is that the client never sees what you're doing. He thinks it's operating normally. Yeah? It's something like, I like to call it, inside my debugger no one can hear you scream. That is kind of creepy. But it's exactly like that. Yeah? So it hits F2, you change the values. I mean, it accepts, of course, some normal arguments. Think, just to have an example in mind, think it accepts some kind of username, whatever. Then you change the username and let it run with a different username. Keep executing, hit some other functions. Eventually, sends a packet to the network, a correct packet, a compliant packet. keep executing, not doing stuff, I don't care, I really don't care about the stuff anymore. Hit some F3 that's somehow arbitrary, and it keeps executing and doing some other stuff. Well, what happens before F1 and after F3, it's really not interesting for me. What's really interesting is this mechanism of generating some packets and sending it through the network. So what's really interesting for me is what happens between F1 and F3. Yeah? So wouldn't it be really, really nice if I could do the following? You can read it here, of course. I can do the following. When I hit the F1, then I'm gonna save the state of the program. Everything, like CPU registers, I'm gonna set the flags, the memory, everything. It executes, I do this really nasty thing to F2, sends the packet, hits F3, whatever happens after F3 is not important to me. So when I hit F3, I'm gonna restore the state. So it's really something like a VMware snapshot. I'm gonna change again the register back, the memory back, everything. So effectively, like closing a loop. So it's gonna move, the client is gonna move just between F1 and F3. And every time it does, I'm gonna change the arguments. Okay, but there's an asterisk there. Yeah. A question? Oh, thank you very much. I have to drink, yeah.
One question. What if you break F2, something inside F2?
Well, it happens a lot, but it's a little bit trial and error.
Automation.
I have a slide, but it's a very good question. I mean, and it's a very good question because he has already realized that this is gonna be a mess because you're touching a lot, you're poking a lot in places where you shouldn't be, and it's a really complicated system. And why there's some asterisk there? Because but this works right now, like yeah. I mean, for this experiment, there's a really simple program that's gonna work. It's like, whoa, it worked. But, I mean, there's a lot of work to be done exactly at that point. And I was talking with some guy that met me here, and he gave me some really, really good ideas. And this, the conclusion is this. But it's gonna work for the, I think it's gonna work for the experiment. So it's really nice to see it, you know? Good, exactly, this is the one. You're really touching like everywhere, and it's a really delicate system, so prepare, it can be something wrong, may happen, prepare for a shitload of crashes while you're working on it. I had crashes everywhere, client server, my tool, because I'm not a programmer. Okay. Very good. Sorry! It's nothing personal. Okay, so, I mean, it's okay if the details are a little obscure, but the idea is clear. It's the same thing as before. Yeah, so the challenge, there's still one point that's like, So I just said, okay, so I can inject some data into the server. How to do this? Like by hijacking the client execution at certain points. Which points do I use? And this is exactly what, how do we identify those functions? So this is really important stuff. Okay, it's not an easy problem actually. Oh, another graph. It's not an easy problem. This is actually from iPad Pro. It's a really tiny piece of a graph of PuTTY. PuTTY, how do you pronounce it? PuTTY.txt, the SSH client. Yeah? I mean, it's a tiny part of PuTTY. And PuTTY is it's a complex thing, but it's just one executable, and it's like 500 kilobytes or something like that. It's not the SAP. So the main problem here, of course, is complexity. Yeah, it's gonna be like really complicated. Yeah, that's why you need tools. Or maybe I'm gonna talk about a tool or road or something. I heard you, very good. Do you know the name of the guy? You can say anything because I don't know. somewhere. Okay, you know much. A lot more than I do. Okay, well, some time ago I wrote an IDA Pro plugin. Now that the IDA Pro guys are not here anymore. I wrote an IDA Pro plugin. The idea, it has a very controversial name. So, very controversial name. It's actually named after my license plate. I'm serious again. Do I look like somebody that can afford an Audi? Yeah, maybe not. True story, bro. Okay, the plugin it's like a mismatch from a lot of functionality. It has some really nice features. It's on GitHub, of course, and yeah, just the typical things that you have to do every time you do some reverse engineering. That helps a little bit. Yeah, so they're really basic things. Like for example, you can say, show me where the network functions are. Show me the functions that connect to those functions. This kind of stuff that is really annoying. Try to automatize this. A much better example of IDA Pro plugin is this IDA Scope. You have the link here. It's a really cool thing. Actually, it won first or second the IDA Pro plugin contest like a week ago. It's a really nice thing, and some guy that maybe is here contributed so directly or indirectly. The very cool thing about IDA Scope is it can analyze the binary and say, okay, I really think those are binary functions. Cryptographic functions, and it's gonna tell you even. I'm pretty sure this is exactly this cryptographic function. So it's really nice. So you can pinpoint the code like now. So go check it out. You can just download it there. And what about this? Everything is static, yeah, with IDA Pro and something without running the code. What about some dynamic analysis? Yeah. Well, I have found that this method is actually really cool. It's called differential debugging, and I'm gonna tell you very quick how it works. Using this, you can as well pinpoint some code that implements a very specific functionality. By the way, do you know the Insecure magazine? Insecure magazine is like some PDF. You can download it right now. This is the latest Insecure magazine. Has a really cool article explaining this with a really cool example in detail. Yeah, if you want to check a little bit more. It's not a broad article or anything, but how does it work? It takes your binary, and then it hooks every single function. I mean, it adds some code to every single function. So that every time a function is executed, it's gonna log. It's gonna, for example, the write to yeah, this function at this address was executed. So you're gonna run your code using this method twice. Yeah, the first time you exercise as many functionalities as possible. You run this thing, and then you start clicking everything, moving the window, just doing the key operations, drop down menus, writing here, everything. You can touch. You have to touch everything, but you cannot touch what you're interested in. That sounds really nasty. And for example, you want to know, okay, in this code, which set of functions implement the login, for example. Then you do the first run, you touch everything, you move the windows, you do almost everything, but you don't log in. That's a very important thing. And then you do a second run. I mean, you now have a really huge file with all the addresses of all the functions that were executed. Then you do a second run, and then you focus exactly on what you want. For example, you run again, and then you go directly and you log in. You click the login button. So you're gonna have a second file, like this. And then you just have to use the first one to filter out the common functions. Because those are things that has nothing to do most of the times with the login. Yeah? So you think, okay, those two are both files, I don't care. and then you get usually a really smaller set of functions, and you just check these 10, 20 functions. It's not like 5,000. Okay, so this is another method. It's like really useful. My point being, it's gonna be complicated, and it's gonna be different every time, because all software is different, even different versions. The functions are gonna be like in different addresses, everything. You gotta try to build your own weapon, or use or modify weapons. I mean, not weapons, tools already there. But there's a lot of frameworks, so you can very quickly do something with it. Whoa. Sorry, say again. Sorry, I'm not really strong. Okay, so it's time for epic ass kicking. But this guy is obviously Boyka. This is a really tough guy that is living in a prison in Russia, somewhere like that. And then this is my software. This is software I'm gonna wrote to this proof of concept. And then we're gonna have, of course, a victim. So a program that's a client, and this is gonna be this Barney. So who do you think is gonna win? That's very easy. Okay, really quick, I'm gonna tell you again what I need. This is the client. We're gonna see it right now in action. This is the awesome client, of course, and it's really easy. It just have some login. You write your login there, then you click the login button, and it's gonna get this text, and it's gonna implement some proprietary protocol. I don't know what it's going with this, what it's gonna do with this text, and it's going to assemble a packet, and then it's going to send it through the network. You can see here this function properly labeled send the shit. It's going to send the packet to the network, and then it's going to keep doing stuff. Okay, so I just analyzed this binary, as I said. Now, I found this function. Yeah, of course I have simple here names. There's nice. I found this function that's called assemble packet. I said, this looks like really interesting. And I checked the arguments, and there's some pointer to a string, and there's some number, among other things. So I say, okay, I'm gonna try to inject some wrong values on those two arguments, and let's see what happens. Okay. The idea is that you don't know the protocol, but in order to make the experiment, I mean that you really understand what happened with the experiment, I'm gonna just cheat and tell you what the protocol is. It's really easy. I mean, you write in this here, you write your login, whatever string, so it's gonna calculate how long this is. It's gonna append the length, I mean this number, to the login itself in ASCII. So it's going to write 26, for example. 26, and then this 26 bytes long login. And then it's going to append a custom string, maybe something like BruCON rocks. And then it's going to encrypt everything and send it to the network. I mean, it's really, really easy. Yeah, it's actually really easy because it's like your login, how long is your login, and then something that is always the same. Where's the problem? What's going to do the server with this protocol? Okay, it's going to get the protocol, it's going to decode this whole thing, and then he knows, okay, here is a custom string, BruCON rocks. Okay, here, what do I have here? The length of the string, and then the string. So I say, okay, this can really, it's a valid. It's a valid packet. I mean, the protocol, everything is right. So I gotta trust this. So I'm gonna take this length, I'm gonna use it to reset some memory, and then copy the string. So you can see the problem, like, yeah, but if you do this, like, you're gonna fuck up. Yeah, exactly. Because the main problem is it's trusting what is happening there. Who's this guy? There's no chocolate, but I mean, there's chocolate left. Who's this guy? You are amazing. It was you. You are a mess as well. Yeah, maybe you can come here. This one is for you. Sorry, I'm biased in this direction. Okay, so the main problem is the protocol is right, so the server says, well, I gotta trust where's the yeah. Good. So yeah, everybody knows it. That was really bad. Sorry. Okay, so really quick. I have two virtual machines. One implementing the server, the other one implementing the protocol. Unfortunately, the resolution is not that good, but it's okay. I think we're gonna make it. Okay. So this is the server. So this is the victim. That's why it's green, because it's like really innocent. I'm gonna resume the other one. I have an SSD drive, like it's really nice. It's like 1 second. So okay, red is always really bad. Okay, something like that. So the client is running here. Is talking with the server. The server just doesn't have any keys because you don't need it. Okay, the server just running here. It listens to whatever protocol, whatever part. I don't see where I am. Okay, much better. Okay, so the server is running. Imagine this is a really big server, running whatever thing. And I have the client that's gonna connect and talk through this protocol. So this is this awesome client. Yeah, let's write whatever login here. Just click the login. It goes through the network and it processes here. So you say I'm not doing any bullshit. What this is really cool. I'll put this, and I'm gonna do like I'm gonna filter just for this. Good. Damn it. No, still not. I just want to click that. Any ideas? I have two windows here. I want to open the other one. Guys, I look like a moron here. Help me. So, yeah. Oh, thank you very much. Good. I'm gonna do like this. Good. So let's do it again. I'm gonna send some beers because I don't have any imagination. I click login. Okay, the service is really cool because you send some bees. Yeah. What does the network says? Here's the data. You send some blah 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 whatever. So there is some proprietary protocol. Yeah. And let's do it another one more time. You gotta be a genius to really. No decryption, yeah. Because, well, guys, I mean, if you have this problem, you get a genius, so you really need this system. But anyway, I mean, you gotta keep it simple. You see the point? It's actually implemented some kind of a coding. It doesn't really matter if it's a stupid one. And then the server is decoding, and this login is just for the demonstration purpose. Yeah? Okay, so it's working. Well, very cool. So what if I try to, of course, do some dumb fast, yeah? Just send some bytes, and those bytes are gonna get exactly like this. I'm gonna hit the server exactly like this. Yeah. Yeah. Of course, I'm gonna get no malform packet because the server is performing some checks. Yeah? It's decoding this, performing some checks. I say like, no, this is not a valid packet. So I cannot do this dumb fast. Okay. So now, very cool. Just to be clean, do it again. This is the server. This is the client. Don't be burning. Very good. So everything works. Very good. And now I'm going to do all the triggering. So I have here this BruCON console that is going to append or attach to this client. It's going to search where's the awesome client here, but you can read the last one. Okay, so it's going to do some kind of DLL injection that is, I know it's a pretty basic stuff, but it's still really sexy. I love to say DLL injection. And okay, so attached to this client, and yeah, you can see some things. It just started to hear on this part, of course, for the communications module, and just found some points and then wrote some breakpoints. So he knows, okay, I hit this F1 or this F3. Do you remember this F1, F3? The close the loop. Okay, this is where it's doing here. Very good. So this is not running independently right now. It's running under the control of this one. Okay? I have the server, so I have to do the same stuff, similar stuff. Good. Cannot read here, but now the server, I'm monitoring the server right now. And it has even connected to the other side. Now they're coordinating the attack. Just wait. Okay. So usually, if I write some A's here, what do you expect? What do you naively expect to see here on the server? Those. Very good. So it's gonna encrypt the whole thing. It's gonna send this packet. The packet's gonna be decrypted, process it. So the A's. Oh, I really hope it works. Looks cool. This has nothing to do with A's. So it's actually just shit, essentially. And you can see here this iteration number. So it's closing the loop the whole time between those 2 points, and it's manipulating or just changing on the fly the parameters of this function. Remember, what was those 2 parameters? There was a string that was supposed to be my login, but I changed it on the fly. And there was this length. This is where it's at. And it's changing both of them. So it's going to start sending just shit. And eventually, it's going to find a combination that is completely wrong. And can't be we have a problem. For the really for the moderately advanced, what problem am I expecting here? What kind of memory corruption? It's really easy. If you think, oh, it's really easy, it's that. Again? It's an overflow, but what kind of overflow? The heap, of course, because I did some malware with it. Okay, sometimes it takes a little bit long, but tune the parameters, so because it's doing like randomly, just selecting from a list of typical fuzziness strings that they usually generate problems. Which iteration is it? 38. Okay, it's gonna take a second. But do you see what's happening right now? I mean, I said like a lot. I mean, I know it's really annoying, but what is happening is exactly this. It's going between 2 points on this execution, and it's modifying the function, the arguments. Take your time. They're gonna kick me out. Does anybody know a joke or something? Maybe we can use it for some questions while it runs. It's not gonna take much longer, so it's oh, no questions. Whoa! Okay, cool. So something wrong happened here, yeah? Ready to receive data. You can see what the problem is. It's like pretty obvious. There's a lot of stuff there, and the length is changed to 512. Yeah? This is way more than 512. So, yeah. And what happened here on the monitor? access violation detected. This is really cool. It writes a crash down, like a, like a mini down. Let's see what happened there. Really quick.
Was ist denn so ein Feuerwehr im Auto? Weil du bist ja noch so transportiert.
Okay.
Die müsste unten in dem...
Yeah, just to be anal. The registers. Do you see those?
War doch noch gar nicht dran. Große Kupfertür.
Do you see these values here? EX, ECX. They're the same. Let's do some kind of. I think it's like this. This is just 30 seconds. Give me 30 seconds. Oh, is it the problem symbol?
Lol.
This is something.
Das wird doch nicht.
This.
Ich glaube schon. Jetzt müssen wir erst mal die Sachen irgendwie ins Hotel bekommen. Dann schaffen wir schon, sind genug Autos draußen.
Try again. Not working. So now it's checking the heap. Just the chain. It's checking if everything is right, because you already know the heap is something like chain. Okay. And there's an error here. It's previous size 6E to 5. That's exactly the same we saw in the register. 6E to 5, 6E to 5. And you're guessing that maybe 6E to 5 is exactly this. And give me just a moment. Exactly. I have to really funky. 6E to 5, 6E to 5. So just tell me what this is an ASCII. So it's of course exactly this. So I managed to, I think this is incredibly cool. I don't know you, but maybe it's just because it's really late, but I don't know the protocol at all. I just did some reverse engineering, but not a lot. I just pointed up some functions that I said, this looks like really funny. I think the could be. I have no idea how this protocol works, and however, I managed to inject some really wrong values and to produce a heap overflow. I found a bug on the other side without knowing the protocol. And I know exactly what the bytes are because they're saved on the other side, of course. Okay. 2 minutes. Bear with me. I'm the last one, guys. So, where to go from here? Of course, much better static or dynamic analysis. You gotta perfect this mechanism to pinpoint the interesting functions. So just to really easily go, okay, I'm gonna check here and here because those are the ones. And of course, the same resource snapshot did work here, but if you try with a bigger software, it's not gonna work. No way, it's gonna crash. And some ideas and maybe the full emulation. Thank you very much for this input. And maybe this is rather new. Maybe this is QML DBI. I don't know. I gotta check. But just do something with this snapshot process. It's not really necessary, but it's really nice. And well, everything is online. You can just laugh at my code there because it's like it's a disaster, but it works sometimes. Yeah, this is my Twitter. You can write me an email. And guys, that's been really nice. I hope you enjoy it as well. Yeah. Don't go without chocolate. Okay, that was. Let's go home.
Thank you very much for this awesome closing talk. It could just as well be the first talk.
Thank you for inviting me.
Do another 2 days. First question: if there's any chocolate left on the ground, the room was already cleaned. I thought it was an awesome initiative, so I didn't disturb you. Please pick up all the chocolates so we can leave the room clean. Oh, sorry. Well, since all my co-organizers already left, they are all dead. I want to thank all of you for 2 long days and a short night. I hope everybody
It wasn't me.
Just speak out loud. Does this still work? They were going to give me one with a working battery. What can I say after all the work that the volunteers put in? I think they deserve a very big round of applause from all the people that are still here. The last thing I want to say is that a lot of people come up to me and say that you do an awesome job on organizing BruCON. I think a lot of the atmosphere is due to the audience being open to share knowledge and just be level with each other. So I want the last round of applause for the attendees of the conference and not for the organizers. Lastly, next year, the 5th edition is going to be a special edition for us. So once the registration is open for the next year's edition, be quick. Have a good trip home.
That's the network.
Ja, ich glaube nicht, dass da noch was passiert. Wo? Sind vielleicht noch 3.000 Leute im Haus.
3000?
3 Dutzend. Bis auf die, die jetzt hier aus dem